Good afternoon. Today we're starting a new unit. This is Unit 11, and it talks about surface area and volume of solids. We are taking all of the learning that we did in the last unit, and we're extending it into a third dimension. Let's see what this looks like. For this lesson, our goal is to understand how to find the volume and the surface area of various different prisms. To do that, we need to first have a quick lesson or reminder of what the parts of prisms are. If you look at this first example, there are two different kinds of prisms there. And so I'm just going to quick talk about some of the vocabulary. One of the most important things to know about prisms is that every prism consists of two bases, which are parallel and congruent shapes. And those two bases are separated by what we call lateral edges. So it's easy to find the base in something like a triangular prism or hexagonal prism or a pentagonal prism, however you say that. They are going to be the two congruent shapes that are parallel, and so they're easy to see here. We name prisms based on the shape of their base. So this I can call a triangular prism because its bases are triangles. When I look at a shape like this, a box, if you will, there are lots of parallel congruent sides, figures. So I could say that the left side and the right side are the bases. I could say the top and the bottom are the bases, or even the front and the back. For this example, I'm going to choose, and I'm going to shade in the left and right. Most of the time, you will either be given the dimensions of the base, or the base will be shaded, like I've just shown here. So these, if I label this, are base edges, and those are the edges that surround and make up the base shape. Those are base edges, and those are the bases. The bases of a prism are separated by what we call lateral faces, and the lateral face in this case would be sort of the top or the bottom, the front and the back. So these are lateral faces. That's a lateral face. In the triangle, it would be the top, the bottom, and the side that I can't really sketch in very well. And just like with a base, you have lateral edges. And these are the edges of the prism that separate the bases. And the lateral edges are important because the lateral edges are where you find the height of your prism. Okay, so that's a little bit about these prisms. Last thing, this one I would call a rectangular prism, just because it is obviously a rectangular shape. There we go. I think we've now labeled them all. There are three important formulas to keep in mind when trying to find the lateral surface area, the total surface area, or the volume of a given prism. The first that we're going to talk about is the lateral surface area. So this would be sort of the wrapper around a box, the part of a cereal box that has the nutritional information and the pretty pictures and the prize in the box, but it would not include the openings on the top and bottom. So that's what our lateral area is, and we find the lateral area by taking the perimeter of the base and multiplying it by the height of the prism. So if I'm looking at this, the perimeter of my base is, so this is the perimeter of the base, that's the distance around the base, and the height is the distance between the bases. And I'm going to write that down because that's pretty important. The distance between the bases. And that sometimes will get confused with the height of a triangle, the height of a trapezoid, because there are other two-dimensional shapes that have a height. But when we're talking about lateral surface area or total surface area, The H always refers to the distance between the two pieces. All right, here's the formula for total surface area. It includes the formula for the lateral surface area. So I need the front, back, left, and right. But for total surface area, I also need to add in the area of the two bases. And that's what the 2B stands for. The B is capitalized because that's the area of the base. And that is a different notation than a lowercase b, which is often used to find area of a two-dimensional trapezoid or a two-dimensional triangle. So capital B, area of the base. Capital P, perimeter, and H is the height of the prism, distance between the two bases. And then finally, a much simpler formula to find the volume of any prism. We simply take the area of the base and multiply it by the height. All right, let's try using these formulas. In example 2, we are asked to name the prism, to find the lateral area, the total area, and the volume. I noticed that there are 3 components that I need to answer these questions. I need to know the perimeter, I need to know the area of the base, and finally I need to know the height of the prism. So let's start by identifying the base. The base in this case has already been shaded in for us as promised. And so if I recognize that this is a rectangle, and I can tell that because it's 8 by 6, and we're only dealing with regular prisms in this lesson. So this is going to be a rectangle, and that allows me to know my shape. A rectangular, y'all know me, spelling's a challenge. This is a rectangular prism. All right, I also like to label my picture, and the first thing I want to do is I want to identify 2 as being the height of my prism, because that's going to be really important. So I'm going to write that over here just so that I have it to reference as I'm doing my other calculations. I'm going to first find perimeter because that's one of the basic constructs that we need. The perimeter of my base is going to be adding up all the sides. So 2 times 8 plus 2 times 6, 8 plus 8, 6 plus 6. Y'all can do that math. And that ends up being 28 units. I also need to find the area of my base. And I know that for a rectangle, I use length times width. You can also use base times height. Base times height is a little confusing in this case because I don't want to confuse it with this number. So I'm going to use length times width, which is really just 8 times 6, or 48 units squared. Now that I've found these 3 basic calculations, measures, then I can simply substitute these numbers into my formulas and use those to find the requisite answers. So my lateral area, we know, is equal to my perimeter times my height. My perimeter is 28 units. And I am going to multiply that by my height, which I said over here was 5. I'm clueless. It's 2. Silly me. That gives me a final lateral area of 56, and it is area, so it's units squared. I bet that was really bothering some of you, wasn't it? My apologies. Okay, total surface area is going to be the perimeter times the height, which we conveniently already know, plus 2 of my bases. I'm just going to substitute this area calculation here in right here, and I'm not going to recalculate that. You can if you choose. And then I'm going to add in 2 times the area of my base, which was 48 units. And from there, I simplify, and that gives me a total surface area of 152 units squared. I'm rocking it out now. The last calculation that they asked me for is volume. Volume is going to be equal to the area of the base times my prism height. In this case, the area of my base is 48, and the height of my prism is 2. When I multiply these two numbers, I end up with a volume that is 96 units cubed. And when we're talking volume of dimensional shapes, it has 3 dimensions. And so our units are cubed, 96 units cubed. And folks, that is how we find the lateral area, total area, and volume of a prism. Okay, folks, you know the basics. These next two examples use the same formulas and the same methodology that we've already talked about. They're just a little bit more complicated because of the shape of the base. So let's walk through a couple of them. This first one, or I should say the fourth example, is a triangular prism. And I know that because my base shape, the two faces that are parallel and congruent, are triangular in shape. So I'm going to write that here. And I am also going to quickly identify the height of my prism because that's really important. I'm going to try to do it correctly this time. I'm going to say the height of my prism is 4. Again, I know that I need to calculate the perimeter of my base shape, and I also need to calculate the area of my base. I notice in this particular case, I am given all 3 sides of my triangle. So calculating my perimeter is straightforward. It's going to be 8 plus 8, the 2 equal sides, plus 12, giving me a total perimeter 28 units. I'm rocking it out now. The last thing I need to do is find the area of my base. I noticed that I wasn't given all the parts that I need to find the area of the base. I'm going to go ahead and draw my shape over here so that I can work with the 2-dimensional object that I'm given. The entire side is 12 units in length, this particular side. And I know it's an isosceles triangle. And if you remember back to our discussions about isosceles triangles, you'll remember that you can drop an altitude, and that because it's an isosceles triangle and the base angles are congruent, the altitude hits at the midpoint. And that tells that this particular small part of my triangle is 6. From here, I can calculate the height of my triangular base by using Pythagorean theorem. If you remember, that would be c squared equals a squared. I like writing formulas, you know me. One of my sides is 6. I do not know the height of my triangle base, but I do know that the hypotenuse of this particular triangle is 8. So I'm going to square that. And I'm going to use Pythagorean theorem to solve for the height of this base. When I do that, I end up with 64 equals 36 plus b squared. And this gives me a beautiful 28 equals b squared. And when I take the square root of both sides and simplify that radical, I end up with 2 square root 7 equals b. And I'm just going to put a note here, height of base. That is helpful because now I actually have enough information to calculate the area of my base. That is going to be 1/2 base times height. That's learning that we had in the last unit. In this case, the entire base is 12. And we just calculated the height of this base as being 2 square root 7. I'm going to simplify. Half of 12 is 6. 6 times 2 is 12. So the area of my base ends up being 12 square root 7 units squared. I can label that as my capital B. That is the area of my base. I now have enough information to calculate the lateral area, total area, and volume. Let's do that. Lateral area, the perimeter base times the height of the prism. In this case, my perimeter was 28 units, and the height of my prism was 4, giving me a total lateral area of 112 units squared. the total surface area, I say surface area, you could also label this as TA, I think I've totally miffed that, but we're gonna go with it. Is the perimeter times the height plus 2 times the area of the base. Well, we already calculated the P times H, so I'm just gonna substitute this in so that I don't have to do that calculation twice. I'm gonna add to that 2 times the area of my base, which in this case is 12 square root 7. When I simplify this, I can multiply the 2 times the 12, but these are not like terms, so I will not be able to simplify it any further than to write it as 112 plus 24 square root 7. So sometimes when we're doing total surface area and volume calculations, our answers can look a little bit complex. That's okay. Hopefully we're used to that by now. The last calculation I was asked to make is the volume of this triangular prism. That is going to be equal to the area of the base times the prism's height. The area of our base in this case is 12 square root 7, and the height of our prism was 4. 12 times 4, 48, square root 7 tags along, and it's units cubed because volume is a 3-dimensional measure. There you go, folks. Another permutation of this problem that you might see is a triangular prism with an equilateral base, in which case you would be able to use your 30, 60, 90 special right triangle information from the last unit in order to find the area of the base. Each situation is different, and you have to look at the information you're given to make that determination. Let's look at one last example before I cut you loose. This last example that we're going to do together, example 5, is a hexagonal prism. We're asked to find the same information as before. The first thing I do is figure out what is the base shape, and in this case, it's a 6-sided figure, and we call that hexagonal prisms. Okay, that said, we need to identify the height of our prism, which again is the distance between the bases. Easiest thing in the world to find in this case. I know I need to find the perimeter. The perimeter of my base shape is going to be the sum of all the sides. There are 6 sides in a hexagon, so 6 times 5. My perimeter comes out to 30 units. And then the last thing I need to calculate for the surface areas and volume formulas is I need to have the area of the base. To find the area of the hexagon 2-dimensional shape, I am going to need to use our formula that we learned in the last unit, which is the area of a hexagon is 1/2 the perimeter times the apothem. So I need to find the apothem. I'm going to draw my small, I'm going to inscribe, I'll draw it over here first. I'm going to inscribe a smaller triangle. I remember that each angle of a hexagon is 120 degrees and that the radius splits that angle equally into 2 parts, giving me a 30, 60, 90 triangle where the 60-degree angle is goes from the mid to the vertex of my base shape, and the apothem goes from the center to the midpoint. So this is going to be my A. I also remember that across from a 60-degree angle, we can represent that side as x square root 3. The short leg across from the 30-degree angle can be represented with an x, and my hypotenuse with a 2x. If I use the information I was given in my original problem, I see that the entire side of my hexagon is 5. That tells me that the distance from the midpoint to the vertex is going to be 2.5. That allows me to rather simply substitute into my 30, 60, 90 triangle, and I learned that the apothem is 2.5 square root 3. Now I'm ready to find the area of my base. The area of my base is going to be equal to 1/2 my perimeter, which we said was 30, times the times my apothem, which we said was 2.5 square root 3. And when I simplify all these lovely calculations, 15 times 2.5, as it turns out, comes to 37.5 square root 3 units squared. You may leave this as a improper fraction, or you can leave it in decimal form. Do not calculate with a calculator what radical 3 is. We always leave our answers inside radical form. So now I have all the units to find the lateral area, total area, and volume. I remember that the lateral area is the perimeter times the height. My perimeter, I remember, is 30 as 12 units. And if I multiply those, I end up with a lateral area of 360. To find my total area, that's going to be my lateral area plus 2 times the area of my base. We've already calculated lateral area, so I'm going to substitute that in rather than recalculate. And then to that, I'm going to add 2 times the area of my base, which we said was 37.5 square root 3. I can simplify 2 times 37.5 square root 3, but again, these are not like terms and will not combine. So I end up with 360 plus 75 square root 3 units squared as my total surface area. I forgot to write this over here. 360 units squared, 360 plus 75 square root 3 units squared. The order that you write these two terms in does not matter. Addition is associative and commutative. Lastly, we're asked to find the volume of our prism. Volume is the area of my base, 37.5 square root 3, times the height of my prism, which we said was 12. And when I simplify that answer, I end up with 450 square root 3 units cubed. It's important to remember this is a three-dimensional shape. Our units are cubed. Folks, you will sometimes find that these numbers, for whatever reason or name, do not read anything into that. That would be coincidence only. We have done a lot of math here. These problems are not overly complicated, but they do require a lot of steps. So stick with it, don't give up, and show all your work. We'll get you there. Thanks.